Welcome to Mickey Study Circle channel. In this video, we shall see how to do the manual drafting of the isometric projection of the combination of the solids. In this video, we shall take up a problem which is having two solids, that is a cone and a hemisphere. So we have got a hemisphere whose diameter is 40 mm and is placed coaxially on the vertex of the cone, which is having a base diameter of 60 mm and a height of 50 mm. So these are the parameters that is given to us. So we have got two solids, that is a hemisphere and a cone. And we have got the hemisphere placed on the vertex of the cone such that the top surface of the hemisphere is facing upwards. So with this data, let us see how to do the orthographic projection of the combination of these solids, and then also see how the isometric projection could be done on the isometric sheet. So before we start the isometric projection, let us do the orthographic projection of the combination of the solids. So let us begin by drawing the reference line, that is the XY line, and drawing the front and the top views of the combination of these solids. So since the top view of the cone resembles a circle, let us mark a point and then draw a circle of that particular diameter. So here the cone is having the base circle diameter of 60 mm. So let us consider the radii to be equal to 30 mm. So I'm going to measure 3 mm, 3 centimeters, that is 30 mm, and then draw the circle so that the diameter of the circle will be equal to 60 mm. So taking the radii as 3 centimeters, and then from the mark point I'm going to draw the circle which represents the top view of the cone. So as already stated in the problem, we have got a hemisphere whose flat surface is facing upwards. So the flat surface of the hemisphere is nothing but a circle again, and this hemisphere is having a diameter of 40 mm. So now we shall draw the top view of the hemisphere, which is also a circle. But however, the diameter will be equal to 40 mm. So we are going to measure the radii of the circle to be equal to 2 centimeters. So I'm going to consider 2 centimeters as the radii. And since it is coaxial, it is having the common center point. So I'm going to draw one more circle which represents the top view of the hemisphere with its flat surface being upwards. So the outer circle represents the top view of the cone, while the inner circle represents the top view of the hemisphere. So with this, we complete drawing the orthographic projections, that is the first view, that is the top view of both the solids. So this is the cone and hemisphere. Now let us just draw the front view. So I'm going to draw the diameter for the reference, and then I'll project it upwards using the straight lines and intersect the XY line. So now let me consider the axis of the solids. So I'm going to draw one more vertical line from the center, and here first let me complete the front view of the cone. So the height of the cone here is 50 mm, so that is 5 centimeters. I'm going to draw the axis of the cone which is equal to 5 centimeters. So this represents the height of the cone, and I'm going to join the axis end point to the end point of these two projectors and complete constructing the cone front view, which is going to appear as a triangle with two slant generators and the base being a straight line. So the outer circle, which is representing the cone, is seen as a triangle in the top, in the front view. So now we have to consider constructing the hemisphere, and since it is coaxial, the axis continues on the same line, but however the hemisphere is having a radii of 2 centimeters. So I'm going to draw the axis again upwards of 2 centimeters. So this is the radii of the hemisphere, and then I'm going to consider drawing the projections from this circle. So let me take up vertical lines from the end points of the diameter of the inner circle and then project them upwards. So through the axis point, I'm going to connect these two end projectors. So you can just see that I'm drawing a 4 mm line, so which represents the top surface of the hemisphere. And to draw the hemisphere, I'm going to consider again drawing a semicircle. So let me just place the compass here and then sweep an arc which represents the hemisphere. So this is the front view of the hemisphere. So you can just see this is the combination of the solids. So you can just see that this is the hemisphere whose diameter is equal to say 40 mm. So let me just represent this here. So this is having a diameter of 40 mm, whereas this is having the diameter of 60 mm. That is, the base of the cone is having the diameter of 60 mm. So let us show the height in the front view. So in the front view, the height of the cone is equal to 50 mm, that is 5 centimeters. And the height of the hemisphere will be equal to 20 mm. So this is 20 mm. So this completes the orthographic projection of the combination of the solids. So now let us see how to represent this on the isometric sheet. So we are going to consider drawing the base circle of the cone. So we are going to consider drawing the circle by using the 4 center point method, and we'll enclose the circle first in a square of 60 cross 60 because the diameter is 60 mm, and then the hemisphere will be drawn, the circle for the hemisphere will be drawn in a square enclosed which is having a dimension of 40 cross 40. So let us see how to do the isometric projection of these solids. So now this is the isometric sheet, and now I'm going to consider one reference point, and from that reference point I'll begin the construction. So here this is the reference point that I'm going to consider. So we are first drawing the base circle of the cone, and since it is having a diameter of 60 mm, I'm going to draw the square of 60 cross 60. So to convert the true scale to the ISO scale, already I'm using the ISO sheet. So I'm just going to draw ISO 60 by joining 6 boxes: 1, 2, 3, 4, 5 and 6. So this is the first side of the square of 60 mm, and next ISO 60 by joining 6 boxes again: 1, 2, 3, 4, 5 and 6. This is the second edge, and next the next edge of the square. So complete by joining 6 boxes: 1, 2, 3, 4, 5 and 6, and the other edge of the square. So this completes the square of 60 cross 60 in the ISO scale. So do not measure the boxes using the true scale, so you might get confused. Just join them by using the actual ISO scale. So now these are the two diagonals of the square that I've drawn. So I told the circle will be constructed using the 4 center point method. So this is the first corner point that I'm going to consider. So from this corner of the square, I'm going to draw a line which is going to intersect the midpoint of the opposite edges. So here it is a line of 60 mm. So the midpoint is at 3. So this is the midpoint. And similarly here, this is the midpoint. So now let me join the lines from the vertex or the corner to the midpoint. So this is the first technique. So I've got the first center as C1 here, and again this is the next center C2. So from C2 I'm going to join the midpoint of the opposite edges. So this is the midpoint here, 1, 2, 3, this is the midpoint here, and next I'm going to complete drawing these two lines. So you can just see that I'm getting 2 point of intersections. So let me call these point of intersection as C3 and then C4. So this is what is the 4-center method. I've identified 4 centers in order to draw the circle in the ISO scale. So the next point is I'm going to consider drawing an arc by using C1. So let me place the compass at C1 and then consider the arc length of this from C1 and then sweep an arc. So this forms the first arc of the circle, that is from C1, and next arc is from the next center point, that is C2. So place your compass at C2 and take the arc length as C2 to this midpoint and then sweep an arc. So the 2 arcs of the circle is generated. So now we'll place the compass at C3 and from C3 measure this distance and then sweep an arc. So this is the next arc. So you have seen that you have generated 3 arcs of the circle. Next I'm going to place the compass at C4, measure this distance and then sweep an arc. So this completes the construction of the circle in the ISO scale. So this is the base circle of the cone. And now the question tells that the cone is having a height of 50 mm. So in order to show the height of 50 mm, I'm going to consider this center point as the origin of the axis of the cone. So from here I'm going to measure ISO 50, that is 5 boxes. 1, 2, 3, 4 and 5. So this is where the axis of the cone terminates. So let me just join them using a straight line. So remember, I'm going to take the origin of the axis at the point of intersection of these 2 perpendicular lines. So 1, ISO 10, ISO 20, ISO 30, ISO 40 and ISO 50. So 5 boxes is completed. Now let me join this vertex in such a way that it forms the tangent to the arcs of the circle like this. So this part is over. So let me just highlight the actual part which is visible to the observer using the darker lines. So I'm going to use the darker shade for the visual representation. So these are the 2 slant edges of the cone, and let me just sweep this. So this arc is visible, this arc is visible, next this arc is visible. So do not highlight the arc which is inside, because that is not visible to the observer. Okay, so this is the first part of the solid, that is the cone is ready, which is having a base diameter of 60 mm and the height of 50 mm. So here the circle is having the ISO scale of 60 mm diameter and the height is of ISO 50 mm. Correct. Next we'll go for the hemisphere part. So the hemisphere is coaxially placed on the vertex of the cone. So this is the vertex of the cone, and in the orthographic projection, as you have seen, so the height of the hemisphere will be equal to 20. So this part is over. The top view 60 mm and the front view 50 mm is done. Now we are going to consider drawing this hemisphere. So the height of the hemisphere will be equal to 20 mm from the apex of the cone. So from the apex of the cone, let me measure ISO 20, that is 2 boxes. So this is the axis of the hemisphere. And now in order to draw the hemisphere of 40 mm diameter circle, I need to consider making a square of 40 cross 40. So what is the procedure? So we'll see that. So now this is the height of the hemisphere. So from this tip, okay, I'm going to consider drawing 2 boxes, that is ISO 20, 1 and 2. Similarly this way, 1 and 2, and next 1 and 2, 1 and 2. So these are the center points for the square. So from this point, ISO 20 on this side and ISO 20 on this side. So the total length is 40 mm, 1, 2, 3, 4. So this being the center. Similarly, let me complete the square of 40 cross 40. So now the square of 40 cross 40 is over. Now I'll just complete the diagonals of this square and then complete the circle by drawing the 4 center method. So from the vertex, join the midpoints. Similarly, from this vertex, join the midpoints of the square. So now the 4 center points are generated. So let me again name this. So this is C1, C2, and then C3, and then C4. So now this part is ready. So now let me complete the top circle of the hemisphere. So from C1, measure C1 to this line and then sweep an arc. Similarly, from C2, measure the distance and sweep an arc. Similarly, from C3 and C4, let me repeat the steps. So C3 to this distance, sweep an arc. Similarly, from C4, measure the distance and then sweep an arc. So the top circle of the hemisphere is ready and it is completely visible to the observer. So let me just highlight the circle part. The construction parts need not be shown. Even if you are erasing it, it is well and good. But here I'm not going to erase so that the construction lines are seen properly. I'm just going to darken the part which is visible. So this is the top surface of the hemisphere which is facing upwards. So now I need to draw the curved part of the hemisphere. In order to do that step, I'm just going to place the compass here at the center of the circle that is drawn. Then I'm going to take a tangent point and then sweep an arc like this. Ensure that the arc is going to be tangent to the extreme points. So this is the hemisphere. So it will just pass through the vertex of the cone. So this completes the construction of the combination of the solids in the isometric scale. So we have got a cone whose base diameter is 60 mm and then the height is ISO 50. So you can just show the length for understanding purpose. So this part is, ISO 50. So technically speaking, an isometric drawing will not have any dimensions on it and the construction lines on it, but for understanding purpose, we need to show the construction lines and also the ISO scale. So I'll represent the height as ISO 50. And similarly, the height of the hemisphere will be equal to ISO 20. So from the vertex, it is 20, 1 and 2, and here it is 50, 1, 2, 3, 4 and 5. So with this we complete the construction of the combination of the solids, that is a hemisphere resting on the vertex of the cone coaxially with its top circle being facing upwards. So this is the isometric projection and this is the orthographic projection. So we need to show both. So this is the XY line followed by the reference planes VP and HP. So this is one part of the construction and this is the second part of the construction. So we need to show both the orthographic as well as the isometric views whenever we are doing the isometric projections. So with this we complete the video. Thank you all for watching.